Okay, so here is a brief video on how to work out the molecular weight of a compound. Now I've chosen this compound here as an example, but these steps are exactly the same regardless of the type of compound that you're trying to work out the molecular weight for. So the first thing we need to do is we need to look at this compound here, and we need to look at the different types of atoms, so the different elements that make up this compound. So we can see that we have a sodium in there. We also have a carbon atom, and we have some oxygen atoms as well. Little trick here, just in case you're not sure, for example, if Na is one single element or if it's two, whenever you have a situation where you have a capital letter and then a lowercase letter, that is one single element. Whenever you have two capital letters together, they're going to be two different elements. So this is actually iodine and then chlorine, okay? So there's a little trick to help. Okay, the next thing we need to do is work out the number of different atoms that we have. And this is really important because we have to pay attention to what we call these tiny subscripts. And I'm going to highlight these in red. We have a tiny subscript here of 2 next to sodium and a tiny subscript here of 3 next to oxygen. So what that means is we actually have 2 sodium atoms, and we also have 3 oxygen atoms. And that's going to be really important when we work out the molecular weight in just a second. There is nothing next to carbon, okay? There is no subscript next to carbon, so we just have 1 carbon atom. The next part is to work out the atomic mass. Now, the atomic mass of sodium, when you go to the periodic table, is 23 after you round it up. Remember, when you go to the periodic table, you're going to see sodium in a little square, and you're going to see 2 numbers. You're going to see the one on the top, which is the atomic number, tells you the number of protons, and then you're going to see the atomic mass at the bottom, which for sodium is approximately 23. So for all of these cases, we're interested in that bottom number there, the atomic mass, always going to be the larger number. Okay, now for sodium, we said that we have 2 sodium atoms, so we do need to times this 23 by 2. That's really important. Carbon, when you go into the periodic table and find carbon, you'll see that it has an atomic mass of 12, and there's only one of them, so we just need to times it by 1. Oxygen, when you go to the periodic table, you'll see it has an atomic mass of 16. We have to be careful here because there are 3 oxygen atoms, so you have to times that by 3. So we then have to add everything up. Okay, so we have to do 23 times by 2 plus our 12 times 1, and then finally plus our 16 times 3. So when you do all of that, you will get an overall answer, final answer of 106 grams per mole. So this is our molecular weight that we need to use. This is really important for things such as when we're trying to work out the moles of something, which I'll show you how to do in a separate video. You need to start off with the molecular weight. It's very important. So